Hi, in this module we're going to talk about the parallel computing patterns. Now, why are we talking about them? Well, the graphics card is essentially a highly parallel instruction processor. And parallel computing, whether it's GPU computing or using multiple CPU cores or using whole clusters of machines, it's got a defined set of patterns which people use to effectively leverage the parallel architectures. So what are the rules of the game when working with GPUs? Well, implementing parallel data structures and algorithms on the GPU is challenging because, first of all, we've got different types of memory. Some local, some shared, some global. We'll get to memory in a later module, but this is something that we're already going to encounter. And then there is the fact that data is stored in arrays. So unlike libraries such as, let's say threading building blocks or the parallel pattern library or something like TPL if we're talking about .NET, unlike those libraries, CUDA doesn't give you parallel data structures or indeed any kind of data structure, parallel or not. In fact, the distinction isn't really applicable here because we're talking about something that's inherently multi-threaded, and also, there is no help from the compiler in the sense that it cannot take a for statement and automatically put it on the GPU as a kind of parallelized loop or kernel. And finally, there is no larger than necessary registers where one can use special instructions to process several bits of data at once. And then there is another small matter which I forgot to discuss previously, and that's the fact that CUDA does proxy things from the underlying compiler, but NVCC doesn't support C++11 constructs, for example, even if the host compiler supports them. And this is because CUDA basically has to parse all the code to actually perform this splitting that we talked about previously. And unfortunately, it doesn't know how to do this at the C++11 level yet. So what are we going to talk about in this module? Well, first of all, we'll discuss briefly the problem with element addressing, because as you may have noticed in the kind of problems that we've tackled, we typically mapped the number of input elements to the number of threads, and it might sometimes work, sometimes it might not work, but when you pile up the dimensions in terms of the grid and block sizes, this becomes a bit of a problem. And then we'll talk about the patterns themselves. So we're going to talk about map, gather, scatter, reduce, and scan. And these are obviously not all the patterns, not all the parallel patterns that exist out there, but they give you a solid foundation to solve some of the common problems that you might encounter.